Welcome once again to our channel. For today, we are going to go through interpretation of graphs. All this while we'll be sketching graphs. Now, the question is, what if you are given a graph and you don't know the equation of the graph? How do you go about figuring out the equation of the graph? So we'll go through this given question and use the example to give further illustration and explanation of this. It says for the given graphs, determine the equation of f and g. If we check here, the f here is linear graph and the g is a parabolic graph. Identification is very important. First of all, we'll think about the general format for each of the graphs. The linear graph is given as mx plus c, where m represents our gradients and c represents our y-intercept. Whereas the parabolic function is given as this. Or the general format is ax squared plus bx plus c. Why did I use this instead of using the format a into x plus b or squared plus q? If I check here, my turning point is at 0. So there's no need for a p here. That's why I opted for the first one. Now let's go through this. We have two methods that we can use to figure out quadratic equations from a given graph. We have what we call the turning point method, when the turning point and one other point is given. In this case, we don't have our turning point. And the second one is what we call the intercept method. So the two x-intercept is given, and that is what we're going to use. The intercept method says this: y equals to a into x minus x1 and x minus x2, where x1 and x2 represent the x-intercept. So what we do is we sub in those values. So we have y equals to x minus 2, that's the first one, and x minus 2 as the second one. Now we call this our original equation, the one we are going to work with. Now we check around if any other coordinate is given. If we check here, this coordinate g is still given on the graph of g. So we sub in that coordinate to get our value of a. So there, y is 5 and x is -3. So we'll have -3 minus 2, and if we simplify this, we have a -3 minus 2 is -1, -3, -2 is -5, so we'll also have 5. So our a is 1. We go back to the original equation and solve our a as 1. So we have 1 into x plus 2 and x minus 2. If we simplify this equation of the graph, we have x squared minus 4 as the equation of the parabolic graph here. Now we've gotten the equation of the parabolic graph, that is the equation of graph of g. Now let's look towards getting the equation of the linear function there. Equation of the linear function there. So for the linear function, we use our c as the y-intercept. But in this case, the y-intercept was not given. So let's first of all get our gradient. Gradient is determined using changing y over changing x. And we have two coordinates here. The coordinate of b is 2 and 0. So if we take our changing y, we can take 5 minus 0 is 5. Change in x is -3 minus 2. So we'll have 5 over -5, and n will be -1. If we look at the shape of the graph, we'll see that we have a negative graph here. So having our this, we can solve in -x plus c. Now, same approach. How do we get our c? Just like we did with a, we solve in a given coordinate into the original equation to get our c, and then after we put it back. Now, if we choose this, y is 5 and x is -3, so we have -3 plus c. So that becomes +3. Our c will be 5. +3 crossing over becomes -3, which is 2. So equation of this graph will be -x plus 2. So our f is negative x plus 2, our y is x squared plus 2. Now we've gotten the equation of our graphs of f and g. Now the next question is asking us to get the coordinates of a, d, and d. In this case, it's not applicable. We have a, we have b, we have d. So the lengths, so let's take this out. We'll come back to coordinates. What do they represent? In this case, telling us our a and b represent the x-intercept, our d is a point of intersection. And then the length of OE, the length of OE, the length of AD, and the length of OC. Let's start with OE. Point E here represents the y-intercept of the linear function. If we look at the graph we arrived at, the y-intercept always represents C. So from here, our y-intercept will be at y equals to 2. So our y-intercept is 0 and 2. So the coordinates of E is 0 and 2. Then the length from 0 to that is 0 to 2. So our OE will be equals to 2 units. Now let's look at our AB. Let's look at our AB. So in this case, AB, the distance from A to B, that's what they're asking for. The distance from A to O is 2 units. It's negative 2, but we don't have negative lengths. So it's 2 units here. O to B is also 2 units. So our AB in general will be 4 units. And then the last, they want us to get the length of OC. The length of OC. First of all, we need to get the coordinates of C. The equation of that parabolic function is x squared minus 4. Where negative 4 represents our q. In this case, our turning point also serves as our y-intercept, where the graph touches y, and it is at negative 4. So the coordinate of C is 0 and negative 4. Therefore, our OC will be the distance from 0 to that point. And from 0 to that point will be 4 units. So our OC is 4 units. So this is what is involved in figuring out or deductions involving graphs and interpreting graphs. We can always calculate our x-intercept by making y 0. We can always calculate our y-intercept by making x 0. We can calculate any given point, our turning point, and use the deductions to figure out the lengths involved in the graph. Please don't forget to ask questions and don't forget to continue to share this video. I will see you in the next video. Enjoy the rest of your day.